All right. So let's see if this works because screen kept going black last time we tried, but it should be okay this time. Soon I try to do something. Okay. Let's try this. Let's try this port. All right. Still recording. Yep. All right. So we're talking about functions. Get ready to have fun. All right. So a function goes from an input, follows a specified rule, and that rule could be linear, exponential, quadratic, absolute value, piecewise, logarithmic, hyperbolic, lots of different rules. And then you get an output. All right. I always think about a vending machine because you have your input, and then you press the button, then you get your output, your candy or healthy snack. All right, so in function notation, this is not multiplication. So those of you not watching the video, and then you think this is multiplication, g times 3, well, it's not. All right, so this, how do we say this? We say g of 3, okay? This is the output of function g for an input of 3. All this language is overcomplicating something very simple, all right? So you can just remember that. What do we actually have to do? What we actually have to do is take this 3, wait for it, and substitute it in. That's it. That is it, okay? So I'm gonna go -5, substitute the 3 in place of r plus 13. And what is -5 times 3? That's -15. -15 plus 13 is -2. So the answer is -2. Ta-da! All right, so that's that. Evaluating functions. Substitute the input, get the output. There's more to it. We can also have graphs. Does everyone remember get, graph, equation table? 3 different representations for one function. All right, so this is a graph of function f. Function f is graphed in blue. We can graph multiple functions on one coordinate plane. All right, and then our input is 1. Now, I do want to say another thing about inputs and outputs. Let's make a little table. The in, the out. Our inputs are x, our outputs are y. So another one. Let's say, independent, dependent. So in science class, I think you should say independent variable, dependent variable. I think that's all. All right, so the x value is 1, and what is the y value? That's the question. So where is x1 on this graph? X is 1 right here. What is the y value when x is 1? Let's go up to the graph. Here's the point. And what is that coordinate pair? 1, 1. See? 1, 1. So in this particular one, both the x and y are 1 at the same time. Now let's do another one. Now this is called a discrete graph. Discrete is like these little dots, you know? And then the opposite would be continuous. And that is no breaks. All right, so discrete, continuous. So on this discrete function, when the input is -5, There's -5. What is the output? Well, let's go find the function value there. And the input of -5 gives an output of -6. All right, so nothing too complicated once you understand what they're asking. Now this one, remember how I was like function f, it's in blue. Well, that's because I was thinking ahead for you to something like this. So now we have two functions. We have function f still in blue, and now function g in a dark shade of red, purple, maroon. All right. So what are we going to do? We're going to substitute in the values here. So when f has an input of 1, and 1 is right here, what is the value of f? It is right here, it is -5. So I'm going to substitute in -5 because that is the value of f of 1. It's 5 times g of 9. What is g of 9? Let's go to 9, which is right here. And g is the maroon function. And it's -6. So I'm going to substitute in -6. So 5 times -5 is -25. And 5 times -6 is -30. So when we add those together, you get -55. So let's see if that's right. Is that right? That's right. So that's how you do that one. That is a commonly missed one, but I hope that helps you. All right. Function inputs and outputs equation. So now we're just playing around here with function notation, saying the input is unknown when the output is -8. The x value is not known when the y value is -8. Okay, so what are we going to do? We're going to, also y is f of x and x is just x. This is another way to write function notation. Instead of xy, we write x and f of x. So our ordered pair, in the old days of October, we wrote x, y. But now we're going to write x, f of x. Pretty cool, huh? All right, so -8 is our f of x. And what is our x? Well, we can only find that by substituting -8 in for f of x. So -8 equals -7x minus 1. And then put our variables on the left and our numbers on the right. And combine like terms. And we'll be out of sight. X is 1. All right. Let's see, is x 1? Sure. Yes, all right. And the last one. Okay. Select all input values for which the output of h of x is 2. Okay, so the y value is 2 at what x values? In order to do this one, I'm going to draw a horizontal line at 2. And where does the function cross that horizontal line? Well, it could cross in multiple spots, but this one only crosses right here. Does everyone see that? Two lines intersect right there. And that happens at an input value of 4 and only 4. All right. Well, have some fun with your functions, and we are definitely going to build on this. This is only the beginning of functions.